Okay, so this week with quadratics, we're going to focus on another thing. Instead of focusing on the vertex points or the max and mins like we did last week, we're not going to focus on those anymore. We're going to focus on a new idea. And the easiest way to kind of show this idea is the real-world application of quadratics. So a lot of the real-world applications of quadratics is throwing an object. So let's say a person has a baseball and they decide to throw the baseball. So there's a different path the baseball would take. You could take a really looping throw, or they could do a straight line throw. Now in either of the two throw types, even in the looping one or the straight line, you get a couple of elements. First off, you get a highest point. That would be the max that we talked about last week. And you get how far the throw went. So you get how far the throw went. This is what we're going to focus on this week. So we're going to be able to find how long the throw stayed in the air and how far the throw went. Finding this process is called the x-intercepts. And the x-intercepts is where the function crosses the x-axis, which would be this axis right here. So it's where the function crosses that x-axis. Another way of saying that is any one of these points has a y value of 0. There's kind of three ways to say it, like x-intercepts, where the function crosses the x-axis, or when y is 0. So what we really care about is the x values of this, because we know y is always going to be 0. So when I look at this function over here, and I look to see, I can see it crosses this point here, and this point here. That point would be x equals -4. And this other point would be x equals 0. Okay. So when I look at the graph, I just look where the parabola would cross the x-axis.